Now we've got the AP Chemistry Polyatomic Ions. It's good to memorize these. Could help out in word problems. So let's get to it. So we've got hydronium. Now, hydronium and hydroxide, you're definitely going to memorize them in the acids and bases unit. So if you have H2O, it gains a proton, which is an H plus ion, and it turns into H3O plus because it has gained an addition of hydrogen and a charge. So we can give H2O, this hydronium ion, it's going to turn into H3O plus. And likewise, if H2O loses a hydronium ion, well, now it lost the hydrogen and it also lost the positive charge. If you're losing positive charges, you're becoming negative. So this is actually going to be the OH minus ion, the hydroxide anion, which is this. Next up, we got mercury. And this is mercury 1. So we have mercury with a +1 charge, another mercury with a +1 charge, and they're bonded together. Hence why it's Hg2. So that's kind of crazy, right? You have like a cation and a cation bonded together. When have you ever seen that? We talk about diatomic. We have like diatomic nitrogen. We have diatomic oxygen. Have you ever heard of diatomic mercury before? Probably not. Ammonium comes from ammonia. So you might have heard of ammonia before, H and NH3. And yeah, once again, if NH3 gains a proton, you become NH4 plus. Acetate, well, acetate, it seems pretty complicated at first, but you can kind of just draw this out. So this is CH3, right? So you have CH3, then it's C, and then OO. So you have oxygen up here, and then you're going to have oxygen right here, and this is going to have a negative charge. Now this is the acetate anion, but you can kind of see how when we actually have a carbon, oxygen, and a hydrogen group, this is something known as an organic acid, also known as carboxylic acid. So you can see how, imagine if I have this structure right over here. Except that this oxygen was bonded to hydrogen. So you can see we have this COOH group right over here, this carboxylic acid group. Now imagine if this carboxylic acid group lost an H plus ion. Well, if you're losing positive charges, you're just becoming more negative and you lost the hydrogen that was originally there. So a lot of these, you can just kind of memorize them from the fact that, well, acids and bases, those concepts. Yeah. So you got the acetate, they got cyanide. Y'all probably heard of cyanide before. You might have heard that cherry pits actually contain a bit of cyanide. Then we have carbonate. So carbonate, it's a little bit of a weird one, but once again, we can sort of connect this back to acids and bases. So when we have water, let's say this is like water in the ocean, and in the atmosphere we have carbon dioxide, right? So when water combines with carbon dioxide, this is going to give you H2CO3. Okay. This is something known as carbonic acid. Now imagine if one of these hydrogens disappeared. So one of these hydrogens disappeared. Acids, right, they like to sort of give away these H plus ions. So if you give away H plus ion from this, you're going to get HCO3, and it's going to be negatively charged. All right, because, well, you've gave away a positive charge. And if I do this again, so I give away another H plus ion, this ion right over here, well, I'm just going to become CO3 2 minus. Now I'm going to gain another negative charge because I have lost another positive charge. And this is actually something known as a polyprotic acid, where you're able to give away more than one H plus ion, all right, from like the total thing that you have. Next up, yeah, hydrogen carbonate. So this is what we talked about here. Or hydrogen carbonate. Whenever you see this hydrogen in front, right, that's gonna give you kind of a little hint about what that thing is. Now we have oxalate. Don't confuse this with chromate and dichromate, all right? This is not a CR, this is a carbon, not a chromate, okay? So make sure to look out for that. Now, the way I like to remember these four is it goes from ite to 8, all right? 8, whenever you hear this 8, that means that it has oxygen. It has more oxygen than ites. Eights have more oxygens than ites, okay? Look at everywhere. Nitrate, NO3 minus, nitrite, NO2 minus. Eights have more oxygens than my ites. All right, see, sulfate, SO4 2 minus, sulfite, SO3 2 minus. See, more oxygens. And yeah, once again, hydrogen sulfate, right? It's just sulfate, except it gained a H plus ion. So it gained a positive charge, so that's why it become only 1 minus, and it gains a hydrogen. Now, hypo, that's the least. Chlorite, then chlorate, and then perchlorate is the most. Chromate, dichromate, just have to remember, I mean, you're going to remember the fact that chromate only has 1, and then dichromate, because this is di, right, that's going to have 2. And the charges are always going to be 2 minus. Just remember that, well, oxygens change. All right, dichromate has more oxygens than chromate. Then you got permanganate. This one's just like a little anomaly. Just got to memorize this. Peroxide, hydrogen peroxide, right? H2O2, right? And in this peroxide right over here, you're going to have this O2 with a 2 minus charge. And then you have this hydrogen. And each of these hydrogens right over here has a positive charge, right? So you can see how like the 2 positive charges balance out this 2 negative charge. But yeah, hydrogen peroxide, that's how you can remember that. Now, phosphate, PO4 3 minus. There's no phosphite here, but phosphite is also a thing. And well, from the name, you'd probably guess that phosphite has less oxygens than phosphate. Once again, eights have more oxygens than ites, all right? And finally, thiocyanate. When you see this word thio, you should be thinking sulfur. So I'm thinking about thio, right? Sulfur. And I'm also thinking about cyanate, all right? And cyanate reminds me of cyanide. So this is going to be a sulfur with my cyanide ion. That's how I remember that one. And thiosulfate, once again, right? Sulfate reminds me of SO4 2 minus. Thio reminds me of another sulfur. So you can see how, imagine sulfate, except one of the sulfurs substituted themselves with one of the oxygens. So then you have S2, O3, and it's going to be the same charge. So that's what you should be thinking when you hear the word thio. Here it is, and good luck.